Good afternoon. Today we're going to do a quick review over solving systems of equations. This is a skill from Algebra 1 that you will need in order to solve some of the problems on your homework, and there will be a systems problem on your unit test. So just one of those integrating algebra skills into geometry type things. So our objective is to review solving systems of equations so we can apply this to geometry problems. Okay, so what is a 2x2 system of linear equations? Basically, it's two linear equations. So if we think about this, you could have a problem like 2x minus 3y equals 0 and 5x plus 7y equals 0. So basically we have two equations and we have two unknown variables. So hence we call this a 2x2 system. You could also have this given to you in different varieties. So we could have y equals 3x minus 5, and you could have 2x equals y. So they're not always set up specifically in one manner. Over on the left here, we have standard form, and these two equations are solved for y. But either way, you can solve them multiple different ways. When we talk about ways to solve systems, you can solve these systems algebraically. You can switch would actually, you could think of algebraically two different ways. You could use elimination, or you could do substitution. If I was looking at the two equations up top, the left one I would solve by elimination. I would either eliminate x or eliminate y. And the right one I would solve by substitution, because if you look here, you have a y here and a y here. So I would take out one of my y's and put in 2x, and ultimately our goal is to get rid of one variable, so we have a one variable equation. So anyway, you can solve them algebraically, you can solve them graphically. The thing about graphically is you're going to basically end up with two lines. They intersect in one point, so there would be one solution. You could end up with parallel lines, so there are no solutions. Or occasionally you have a line, and when you graph your next line, it graphs over it, and this is a case that you would have infinite solutions. So traditionally we solve systems algebraically, and we solve them graphically. All right, so let's see what they look like. I have the system negative 3x plus 4y equals negative 18, and another equation 10x plus 6y equals 2. When I look at this system, there are two variables and two equations, so this is a 2x2 system. My goal is to eliminate one of the variables. So when I think about what is going on with this, I either need to make x and x opposites, or I need to make y's opposites. So it doesn't really matter on this one. So I think I'll eliminate, I will make the x's the same and eliminate the x's. So 10 times negative 3 is 30, so I'm going to multiply this bottom row by 3, and I'm going to multiply everything in the top row by 10. And if you don't understand why I chose those numbers, you will in a second. So I'm going to distribute that 10 to everything in the top row, so you get negative 30x plus 40y equals negative 180, kind of a big number, but we'll work with it. In the bottom row, you're going to distribute this 3 to everything in the bottom row. So 3 times 10x is 30x. 3 times 6y is 18y. And 3 times 2 is 6. So some people will call this method combination because we're going to combine the equations in order to eliminate a variable. My goal was to eliminate x, so now when I look at these two variables here and I add these two together, these go away, and that was kind of part of why I chose the 10 and the 3, is because I needed those to be opposites. So this becomes 58y equals negative 174. And I'm going to divide by 58. And I'm pretty sure 58 goes into 174 3 times. Yes, it does. So y equals negative 3. Now, I am not finished. I have found y, and it asks to solve the system, so I can pick either of these equations, and I'm going to substitute y back in. So you have negative 3x plus 4 times negative 3 equals negative 18. Negative 3x minus 12 equals negative 18. So negative 3x equals negative 6. And in the end, x equals positive 2. And it would not have mattered if you want to do a quick check. You could have taken that y equals negative 3 and put it in the second equation. So if you had 10x plus 6 times negative 3 equals 2. So we'll just verify that. You get minus 18 equals 2. 10x equals 20, and x equals 2. So this actually is an ordered pair 2, 3. So if you graph these two lines, or I'm sorry, 2, negative 3, they would intersect down here at the point 2, negative 3. So this actually ends up being an ordered pair because it is a point. So I would like for you to write your answers in an ordered pair. All right, just to make sure you're on the right track, I want you to hit pause. I want you to do this problem and rejoin me when you're done, and let's see if you did it correctly. All right, welcome back. In this particular problem, I think I am going to eliminate y this time just to choose something different. So I have a 5 and a 6, and they both go into 30. So I'm going to multiply this by 6 and this by 5. One of them needs a sign change, and here's the thing with this equation. You could have done it a different way, so if you did, do not erase it. Let's just see if you got the same answer. So I get negative 18x plus 30y equals negative 18. 5 times 8 is 40, so I have 40x minus 30y, and 5 times 14 is 70, negative 70, because that's a negative. So I eliminated my y's this time, so 40 minus 18 is 22x equals 70 minus negative 70 plus negative 18 is negative 88, and x is going to equal negative 4. So if you got negative 4, even if you did it differently, you did it correctly. So there's 3 or 4 different ways you could have approached this problem. So if x is negative 4, I'm just going to substitute this back into the first equation. So you get negative 12 minus 5y equals 3. I'm going to move my 12 over, so negative 5y equals 15, and y equals negative 3. So this is an ordered pair. So again, if you graph those two lines, they would intersect in the point negative 4, 3. All right. So you'll have some problems on your assignment coming up in the next section that involve systems of equations, and hopefully you will be able to tackle them at this point. Have a great day, and I will see you in class tomorrow.